So, welcome to module 9.5. So, what we have seen so far is to take a Jack program and convert it to a set of tokens. These tokens have what we call as lexical elements, and the grammar had 5 lexical elements, namely string constant, integer constant, symbol, terminal and identifier. So now once you have split the entire program into these lexical elements, now the next step is to take the set of tokens. Now you have a file in which there is one token per line and it is a stream of tokens. Now we want to see whether that stream of tokens actually adhere or to the grammar, right? That is called parsing. And in the act of actually checking whether this adheres to the grammar, right, we also form another XML file with certain labels inserted, so that will be useful for our code generation. So now we have just a stream of tokens from the Jack. Every entity, every lexical element got converted to a set of tokens. Now we will take this stream of tokens, one per line, and now we will create another XML file which will not only check whether this grammar adheres to whether this tokens adhere to the grammar, but also will insert certain more labels so that it becomes easy for code generation, right. So that is the second part of your project 10, right. Now let us go and see how this is going to work. So here is it. So when you see here, so this complete thing has been used for your, this is completely used, all these lexical elements have been used by a tokenizer, which we have done. The remaining 3 parts of the story, namely these rules, which basically has the program structure and then followed. So the program structure basically has class. The class rule essentially will contain the keyword class followed by the name of that class, which is an identifier, then open of the braces, then it will have 0 or more class variable declaration. This class variable declaration star is 0 or more class variable declaration, followed by 0 or more subroutine declaration, ending with the end of this parenthesis. So the class variable declaration in turn will have static or field. One of this pipe actually stands for, in this case I am moving the cursor here, the pipe actually stands for either static or field, then type, then var name, it will be an identifier, followed by comma and 0 or more var names, ending with a semicolon. Your type can be int, char, boolean, class name, etc. So if I have, so just to start here with it, let us say I have field int x, this adheres to this. So this class variable declaration, so there is the rule class variable declaration will first see field or int. Yes, it sees field, then field or static, it sees field. Now it goes after the static or field, you need to have type. Now yes, and the type is one of this int, char, boolean or class name. So this adheres to the type. Then you need a var name, this is an identifier, this is var name, followed by comma var name. I could have 0 or more comma var name. The star essentially says I could have 0 or more comma var name. Yes, I had 0 here, and then I have the semicolon here. So I have the semicolon here, this comes to semicolon. So this particular statement basically adheres to this rule, right. Now how do we go? So this we have seen in some understanding, we have seen what we call as what we have this particular how do we interpret these statements, we have actually seen in module 9.3 sorry, module 9.4, and now we will now see how do we implement this. Okay. So for every non-terminal that we are seeing, so terminal is something, all the lexical elements are called terminals because you do not have anything beyond them, right. But if all that you see in the second part of this this program structure, all that you see here, these are all non-terminals, because after this there is something. So what does the class have? Class has a keyword called class, then class name and something more, but a terminal like integer constant has nothing more. So that's why it's called terminal end. Okay. Now what we do here is as follows. Right. So what we do here is as follows. So we write these routines, right. So so we write these routines. So and this will basically do the following. So I will have something called compile class. That will be my first routine, because every file starts with, every token file will start with tokens. So in this implementation, you write another C program that will read one by one the token and do the following. First it will read, the file will read tokens, right. It need not do anything. So it will read tokens and first check that it is indeed a token file. Okay. So this is tokens, right. So tokens will be the first entry in your tokenized file. So it just reads it and that's it. Then you call a routine called compile class, right. Now so after this tokens, normally you will see a class, right. You have to see a class. So you should see something called, in the token file you will see something called keyword class / keyword, right. So let us even see one example for this. So whatever we have done in the previous thing. So let us go and see. So one of these tokens. Okay. I am opening this. Yeah. First thing, whatever you see is tokens. The second thing immediately you will see is keys, class. The moment I see class, you call this routine called compile class. The moment I see class, you call this routine called compile class. And what will compile class do? Now how do we write the code for compile class? Let us keep this here. Now we go back to the grammar. So the compile class is the routine that I am showing here, right. Now we go back to the grammar. Very quickly we go back to the grammar. So let us look at this, right. The compile class should first check whether keyword class is there. First token is keyword / keyword, that it needs to check whether that token is there. Then read the next token and see if it is going to be an identifier, because class name, the next thing is class name, as you see here. The next thing is class name, and the class name is an identifier. Next you go and check whether identifier is there. So if I find the keyword class, immediately go and say yes, keyword class is there, immediately output that token. So what will this, so compile class will do? So the moment I see class, I will write on the, so whatever I am writing on green is the output here. So when I start reading that file, I will see first tokens. I don't do anything with tokens, it is some magic number which basically says yes, this is token file. Now the first thing I need to see is class. The moment I see class, I will call the routine compile class. So before calling that routine compile class, so you do this, you just write class and then call the routine compile class. What will the compile class do? It will see first that is given by this rule here. It will first see whether the next token is of the type keyword class slash keyword. If it is of the type, immediately output that token with 2 spaces here. Just give 2 spaces. This is the format in which the project wants you to do. So, just we will follow that format. So, give 2 spaces here, and then 2 spaces would be blank here. Then write keyword class slash keyword, right. Then you read the next token. So, you read the next token, and what will the next token do? It will now find out, then we need to find whether it is a class name. According to this rule, the compile class should check whether it is a class name. So, it will check if there is an identifier. The class name essentially directly goes to an identifier. So, you will check whether there is an identifier. Yes, there is an identifier. So, just output that identifier again with these 2 spaces, identifier, some name will be there, and slash identifier, the same token, you just put the token. After that, you have to check for a symbol of this form, slash symbol. So, you write that symbol also here, symbol slash symbol, right. Then there can be this classware declaration or not. Okay. So, this star essentially means that there can be 0 or more classware declaration, right. So, what we need to do is we go and check. So, we have finished off the 3 tokens. Let us go back to this token files, right. So, the first token was, as you see here, class, second was main, then third was symbol. Now, we need to go and see if there are some classware declaration. If there was some classware declaration, class variable declaration, then the next should be a keyword static or a keyword field. So, that we see here. So, right. So, if there is going to be any classware declaration at all, then the next token should be either static or field. If the next token is not static or field, then you know that this is gone, this star. So, there is no class variable at all for this particular say. Class need not have variables. Then we go and start looking at subroutine declaration. So, what we do is, now we go and after you do here, we go and check whether there is going to be an keyword which is either static or it is going to be keyword static keyword or keyword field keyword. If that is going to be there, then immediately you write with the 2 spaces here class var dec, and here you call this compile class var dec. This is another routine. Now, currently it was compile class, that compile class will now call compile class var dec, right. Now, what will compile class var dec do? We will do later. After that compile class var dec finishes, we will again come back and output slash class var dec again with the same 2 spaces here from this, right. Now, if I do not find the next keyword as static or field at this point, then there is nothing, there is no class var dec. That is what this class var dec star means. Again I am repeating, star means there can be 0 or more class var dec. Now, you go and see subroutine dec. Now, then you go and see whether there is subroutine dec or not. What you will see, the next keyword you go and see, next token you can see whether it is constructor, function, method, one of this should be there. If it is there, then it is subroutine dec, otherwise nothing is there. So, you go and check after you finish this class var dec here, then you go and check the next token whether it is constructor, function or method. If it is there, then again what you do, again with the same indentation, you just write it is subroutine dec, subroutine declaration. Then you again here you are calling compile subroutine declaration. After this fellow finishes, you again come back and write slash subroutine declaration DEC, and then come back and align this and write slash class. Okay. So, essentially what will be here is whatever is output by this compile classware DEC, that will be part of the state, and what will be output by compile subroutine will be part of this state, will be part of this output. Okay. Right. Okay. So, this is how compile class will do. So, compile class will check for keyword, first it will put class there, and then it will check for keyword class. If it is there is a keyword class, it puts with 2 indentations, 2 spaces, all the outputs it will put with 2 till it comes to classware DEC. If there is some classware declaration, then only you put these 2 statements, right, classware DEC, and then this and this and this, right. Now, what will compile classware DEC do? Compile classware DEC will go and see, okay, whether the current token is static or field, it will output that token. So, let us see what compile classware DEC does. So, it is here. So, I am just erasing this to tell you what it is going to do. So, compile classware DEC, again you go to the rule here, classware DEC, it will check whether static field, if it is there, yes, it is going to be there because you have already checked. You now put here keyword, let us say without loss of generality it is static slash keyword, but again with 2 gaps here from this. So, this is 4 gaps from the beginning, right. Then it will go and check if there is a type. Again the type can be, as you see here, the type, where is the type, you can go here and see your type. Type can be int, char, boolean or some class name. So, it will check for the type. So, the type can be either a symbol, keywords like int, char, boolean, or an identifier like class name. So, you can put it here, and then it will go and check if there is a variable name, there is another identifier which is a variable name, then it will check whether there is then it will check whether there is a comma. If there is a comma, then there are more variables there. If there is no comma, then there is nothing. So, I could have, so essentially this rule captures something like static, for example, int static int I comma j comma k, wherein there are 3 variables here after static int. I could have also have it as static int I, that is all. So, there is only one variable. So, that accounts for. So, this class variable declaration should start with 3, that will have say minimum 3 tokens. The first token will be of the type keyword, static or keyword field. Second would be of type, it is again a keyword int, keyword char, keyword boolean or keyword identifier class name. So, that will be one of these tokens next, and then this var name should actually be an identifier, that should followed by an identifier, and then I could have comma and more identifiers or not, and it should end with a semicolon. So, I will check for the semicolon. So, all those tokens, when as and when I see here, I will also keep dumping it here as a part of this original file with 2 spaces away, right. That is it. Similarly, we will go. So, now classware DEC finishes here. Now, we will see I have to write for subroutine declaration. So, subroutine declaration will now go to subroutine body. The subroutine body will have variable declarations which is of this form var type, var name, comma, var name star. So, it will call compile. So, the compile subroutine DEC will call compile subroutine body. Compile subroutine body will first call compile var DEC, and then it will call compile statements. The statements will have 0 or more statement, the plural, and this is singular, and each statement will be let, if, while, do, return. Each let statement will become let, var name, expression, etc., and it goes on. So, whenever I am calling a particular subroutine, compile subroutine, I write that name, right, and with I write that header there. So, class var_dec, for example, I am calling I am calling variable declaration class var_dec. So, I put slash class var_dec, then call compile class var_dec, and again after I come back I put this class var_dec. So, these are the labels that I am inserting into this entire stuff. So, I will just give an example. So, this is how you write the entire grammar one after one very carefully, but I will give you some more clues also before we go forward. So, let me take these two files, right. So, so I am taking both of these files. And let us see it side by side. So, first tokens get ignored, then keyword class. The moment I see class, I have outputted class, then keyword class / keyword. Then I need an identifier, that is main. So, main. Sorry, I opened the wrong file. 1 minute just. So, this is main.a. Yeah. So, your main identifier main, then symbol slash. So, note that I have given 2 spaces here, right. So, there are 2 spaces that are given here. Then class var_dec, because since I see a static here, I have now gone to class var_dec, and so that has static keyword, then type, this boolean is for that type, and then identifier is the test, and then semicolon. So, that is one class var declaration. Then I am having function void main. So, that is a subroutine declaration. So, I call subroutine declaration again within the subroutine declaration. Now, the subroutine declaration now finds function void main and then parameter list and so on. So, we go by the grammar as and when. So, whenever I so in the grammar when we are when we are coding, so this is how we code the entire stuff. So, let us go back to this main routine here. So, this is the entire code that we have written. Yeah, for our quick understanding. So, we will just keep it at, yeah. So, for our quick understanding here, so when we say compile class, right, we want to before we call compile class. So, let us go back to the main routine. So, this is the main function. Again we have argc, argv. So, it takes a file inside which is a token file and it gives you a analyzed file. The first thing that we do here is that we just ask, have we read that. So, we have something called, so what we need to maintain here is one global variable called next token and a global variable called consumed. So, you keep reading from this file. So, different subroutines will be reading from this token. So, it is better that we have the input file, output file, the token, everything as global variables, so that any routine can start reading from it. So, every routine, so we have 2 variables, one is called next token, another is called consumed. Consumed is a boolean variable, next token is a string. So, the next token will you will read a token, and if the token is not written into the new file. So, if whenever you read a token, finally the token gets returned into the file, right. So, that is what we are seeing. So, what we have done here, just to again go back and tell you, so all these tokens we have reproduced here. So, this is the what you see on the left hand side is the input file, the right hand side is the output file. All the tokens that we have seen here are again reproduced here, but with insertions of some labels like class, class_var_dec, subroutine dec, etc. And this will be useful, what you see on the right hand side will be useful for code generation. So, that is the analysis that we have done here, right. So, what we do here, so basically every time you consume a token and you say that consume a token means you read a token and then you say that it is still yet to be used, it is still to be returned back, and if you read the token into this global variable called next token, and you find out whether that first thing that you check is it is tokens or not. So, normally every executable file will read the first part, and there will be a magic number which tells what sort of executable it is. You will have for Windows operating system we have a different executable, for Intel architecture we have different executable, for Sun we have different executable. So, what sort of executable it is, what sort of file it is, file type. So, that is always there on the top of the file. There will be some magic number by which the operating system will identify what is this file. Okay. So, here by looking at this tokens, it will say it is a tokenized file for Jack or what for the virtual machine, right. Then what you do, the next thing is you consume the next token and you check whether that token is of the type class, and if it is of the type class, if it is not of the type class, you just say there is an error, but if it is of the type class, you immediately write class, then you call this compile class, and after that compile class returns, you just write /class, that is all, right. So, this is what we need to do, right. At the end we go and check whether there are /tokens, etc. So, this is how your main file does. Now, we will go to compile class. So we will now see what is compile class, right. So, this is compile class. So, I have something called spaces. Spaces tells me how many spaces we have moved, and spaces also we can have it as a global variable. So, I am incrementing the spaces by 2. Now, I have already seen this class, that is why I have come here, the keyword class keyword. So, I print token with spaces, this many spaces, right, and now I say I have consumed it. So, the moment I have printed, so consumed equal to true. Now, I consume the next token and I check if it is an identifier, right. So, how do I check whether it is an identifier? So, I just see if the so it will be of the form less than symbol, identifier greater than symbol, right. So, how do you check something is an identifier? This is the way we go about checking it. So, it will be of the form identifier /identifier. So, you go and check from the first character to the so the first character to the 10th character, or first to 10th is of the form identifier, right. You can check that, and if it is identifier, if that is correct, then we can say okay. So, the next fellow is an identifier. So, I will go and check if there is an identifier, and the check identifier, if it is an identifier, it will take and print it. We need to just print it. Then we take the next token and see if it is of the form symbol with this. If it is yes, then fine. Then now we go and see, we consume the next token and see if your next token is of the form static or field. If it is of the form static or field, then you say class_var_dec and you call compile class_var_dec, and after that you finish /class_var_dec. And I have written a while statement here because it can be class_var_dec star. If you look at the grammar for this, it was class_var_dec star. So, it can be 0 or many class_var declaration, right. Similarly, I go and check whether this is I go and check if the next is a constructor or function or method, right. That means then it is a subroutine declaration. And again I put a while statement because we have subroutine dec star. Okay, so that's the statement here, right? So let us go back and see here. So we have subroutine dec star for the compile class, right? And the subroutine, whether there will be that or not, is going to be given by this constructor. So the moment I find that yes, there is a subroutine, then I'll call the routine call compile subroutine declaration. So and that will take care of it, and then just print it. So the same thing. So what I have described here, I am also showing you the code of how I have coded this class. But the same thing I follow for subroutine dec, the same thing I follow for class_var dec. So for all, so these are all the routines that we need to do as a part of this project. And so compile class_var dec. So these are all part of the slide for chapter 10 in the website. You can just refer that. Compile class_var dec, compile subroutine dec, compile parameter list, compile subroutine body, and then compile subroutine body, compile var dec, compile statements, compile let, compile if, compile while, compile do, and compile return, compile expression, term, and expression list. So for the three entities that we saw on the grammar, that we saw in the here, yeah. So for this entity, and this entity, for these three entities, these are the subroutines that we will be writing. Other rules we just express it directly. So these are the subroutine for the first second section. The first section was lexical in the second section. These are the subroutines for the third section, and these are the subroutines for the fourth section. So this is how we write the program. And every time I call a subroutine, before calling the subroutine, put the name of that subroutine minus that call, right, or compile, right, that name of the subroutine, print it within less than greater than, and after you finish executing the subroutine, again print slash of that, so as we have described here, and that is the file that we need to basically generate, right. So once this is generated, this code, basically we can compile this code. So and so that will give us another XML file of this form, so which I can show you here. This is the XML file. So we can open this XML file in a browser, then it makes actually you can also open it with Internet Explorer. Right. So we can open this. So we have to rename this. So yeah, one of the difficulties with Internet Explorer, you have to, I have just named it as analyzed file, ANZ. I have to rename it as XML file. So then only it will work. So let us go back to this then project. So so this is the XML file that you will get here, right, and this is the output that we need to get out of this course, right. So we will I'll give you the actual implementation details of project 10 in module 9.6, but you can start coding with these inputs. Thank you.